In this video, we'll define the absolute value of a number, and then we'll learn to sketch the graph of absolute value. Then we'll have to think a little bit of what we allow to do. For example, if we have the absolute value of x plus 2, are we allowed to say that that's the same as the absolute value of x plus 2? And finally, we will be wondering how to graph y equal to absolute value of f of x. Note the absolute value is there if you already know how to sketch the graph of f. Let's first define the absolute value of a number. The absolute value of any number will always be a non-negative number, right? So let's see how we achieve this. We decide that if we start with a positive number or with 0, well, it's already non-negative, so there's nothing to do, and we leave it as is. Now, if x is negative, then that's not what we want. We want something positive in the end. What we will do is just multiply it by -1, or if you'd like, just put a negative sign in front of it, and you will get a positive number. Let's try. The absolute value of 1, well, we just follow the rule. That's the absolute value of a positive number. Leave the number as is, and we get 1. Absolute value of 0, same thing, the same rule says, don't do anything. Get 0. And then the absolute value of 7 minus square root of 3. It turns out that square root of 3 is equal to 1.7 roughly. So that's a positive number. The rule says the absolute value of a positive number is the number itself. Now, for the first time, absolute value of a negative number. The rule says if your number is negative, you multiply it by -1, or if you'd like, you put a negative sign in front of it. So we get minus 1, which is +1. And we indeed got a non-negative number. That's what the absolute value does. Last example. Again, square root of 3 is more or less equal to 1.7, so if you subtract 7, that's negative. The rule is, if you take the absolute value of a negative number, the way to do this is just put a negative sign in front of it in order to make things positive. So we get square root of 3 minus 7, and this is minus square root of 3 plus 7, which is indeed a positive number. So now let's look at the formal definition of the absolute value, which is there. It's really rewriting the same thing as above, but using mathematical symbol. So here we're saying the absolute value of x is going to be the number itself if the number is positive, which is exactly what we had earlier. And the second thing we said is if it's negative, just put a negative sign in front of it. And here it says, if it's negative, just put a negative sign in front of your initial number. In both cases, you will get a non-negative number. So this defines a function. And we like to know the graph of the functions we have. So this graph will really be made of two parts. If x is greater than or equal to 0, absolute value of x is really x. So we're sketching the graph y equal to x. We recognize this one. That's a straight line. When x is 0, y is 0. When x is 1, y is 1. That gives us this 2 point. When x is 2, y is 2. And that gives us the portion of the graph that correspond to values of x which are greater than or equal to 0. Now let's look at what happens if x is negative. Then we're sketching y equal to absolute value of x, but we know that if x is negative, that's really y equal to -x. Again, that's the equation of a straight line, and again, we could pick a few values. When x is -1, the absolute value of -1 is 1. If x is -2, its absolute value is 2. So that gives us these 2 points, and that gives us the other portion of the graph. Now, if you put these two portions of the graph together, this V shape is the absolute value. Sometimes, having an absolute value in an expression like this one can make the calculations difficult. So sometimes we try to rewrite an expression without absolute value, but the price to pay for that is usually that you get a different expression depending on the values of x. And that's exactly what we've had with the piecewise defined function. Let's do this on an example. So if our function is defined by f of x is equal to absolute value of x minus 3, and we want to rewrite this without absolute value, well, that's going to depend on the sign of x minus 3. Because as we said, if the number inside the absolute value is greater than or equal to 0, then the absolute value of the number x minus 3 will be the number itself. On the other hand, according to the definition of the absolute value, if the number x minus 3 is negative, then the way to get its absolute value would be to put a negative sign in front of it. And in that case, we would get minus x plus 3. Now we can rewrite this using the usual format of piecewise defined function. So f of x, which, if you'd like, is absolute value of x minus 3, can be equal to one of those two things. It can be equal to x minus 3, and that's the case if x minus 3 is greater than or equal to 0, which is the same as x is greater than 3. I'm actually looking here, right? And it can also be equal to minus x plus 3, and this happens if x minus 3 is negative, which is the same as saying that x is less than 3. So I rewrite this here. Absolute value of x minus 3 is minus x plus 3, and this happens if x is less than 3. Now we want to sketch the graph of this function, and we can use what we did, because we said if x is greater than or equal to 3, then y, which is the same as f of x, will be equal to x minus 3. And we recognize the equation of a straight line. We can find a few values if we'd like. When x is 3, y is 0. I'm just subbing into this formula here. And when x is 4, I'm getting 1. So when x is 3, I get 0. When x is 4, I'm getting 1. And I get this shape. And I even know the equation of this part of the graph. Now let's look at what happens when x is less than 3. That's the other part of the graph. So our graph will be y is equal to f of x. And as we've seen earlier, that's minus x plus 3. Just using this here. We know that this is the equation of a straight line, and we can get this by picking a few values. I'm going to pick values which are less than 3 because of this constraint. So I could try, for example, when x is 0, I'm getting 3, and when x is 1, I'm getting 2. So when x is 0, I'm getting 3, when x is 1, I'm getting 2, when x is 2, I'm getting 1. And I'm getting this other part of the graph, and its equation is minus x plus 3. For this specific graph, we didn't really need to go through all of that, but we wanted you to practice getting rid of the absolute value by using a different definition depending on the values of x. Really, for this one, what we could have done is use the fact we know the graph of y equal to absolute value of x by heart, and this one was obtained by subtracting 3 to x, which means we just shift the graph 3 units to the right. And indeed, our usual absolute value graph is there, and it shouldn't be pushed 3 units to the right. Now let's see what we are allowed to do and not allowed to do with the absolute value. Lucky for us, it's the exact same story as square root. Remember how when you add the square root of a product or the square root of a quotient, you could just break the square root? Well, it's going to be the same here. If you have the absolute value of a product, you can actually break your absolute value. If you have the absolute value of a quotient, that's the same as the quotient of the absolute value. So everything works fine with multiplication and division. The problem arises when you have addition. The absolute value of a sum will sometimes be the same as absolute value of a plus b, and sometimes it will not be. Try to think for a few seconds of a case when they would not be equal. You may pause this video, try to find an example, and then write it down there. Okay, welcome back. So let's see an example which would work. You could just pick a is equal to 2 and b is equal to, let's say, -3, for example. And in that case, the absolute value of a plus b is the absolute value of 2 minus 3. That's the absolute value of -1, which is 1. But the absolute value of a plus the absolute value of b is actually 2 plus 3, and that's 5. They are different. So if you've been playing with a few examples, you probably noticed that if you start with two positive numbers, since they're equal to their absolute value, this equality will hold. If you start with two negative numbers, it will also hold. The problem is if your two numbers don't have the same sign. So the equality holds if your numbers have the same sign. So same sign. Well, so it's not always true that the equality holds, but it will, as a consolation prize, you can see that the inequality is always true, and this inequality is called triangle inequality. You won't really need it, but at least if you remember that the inequality is true, maybe you will remember that the equality is not. Let's get a little bit of practice with those rules. So, are we allowed to say that these two things are equal? Let's start from the left-hand side and try to get to the right-hand side. So if we start from the left-hand side, we have the absolute value of 3x minus 6. And the first thing we could do is factorize a 3 inside the absolute value. And that's, of course, allowed. We're just inside the absolute value. We haven't done anything. The next thing we want to do is break this absolute value into the product of two absolute value. And we recognize our rule number 1 up there. So yes, this is allowed. And this is 3 times absolute value of x minus 2. So that means that this is true. Let's look at the second one. It really looks like what's been done here is to break it this way. So really breaking an absolute value when what was inside was a sum. And we say, no, don't do that. In general, that won't hold. One way of proving that something is not true is just to find a counterexample. So the question is this true for all x? And if you just try x is equal to 0, your left-hand side will be equal to 6, whereas your right-hand side will be equal to -6, so they're not equal. So B is false. So what about the last one? Again, let's try to see how we could go from the left-hand side to the right-hand side. So the left-hand side is the absolute value of a quotient. Our rule number 2 tells us that the absolute value of a quotient is the quotient of the absolute value, so we can break where the absolute value is over x plus 2. And from there we clearly have the right-hand side because the absolute value of -1 is equal to 1. We got the right-hand side, and that means that this is true. Now let's see. If you look at this graph here, it's the graph of a pretty normal parabola, except we've put an absolute value around here. So in general, we're wondering how we could graph y equal to absolute value of f of x if we know how to graph f. So let's look at this example. F of x is just a quadratic. By now, the second you see a quadratic, a parabola pops in your head. Another thing that should be pretty clear is if the number in front of x squared, so when there's nothing, it means it's a 1. If it's positive, your parabola is opening up. So we know our graph looks like this. To make this precise, we could try to look for the x-intercepts. And the way to find the x-intercept is always the same. You solve the equation y equal to 0, or f of x equal to 0. In that case, x squared plus 2x minus 8 is equal to 0. That's our quadratic equation, so we try to solve it by factorizing for about 20 seconds, and if we can't factorize, then we just give up and use the quadratic formula. So we need two numbers which multiply to give -8, really the product of the coefficient of x squared, and so the coefficient of x squared, so that's the 1, and the constant term, that's our negative x. And our two numbers need to add to the coefficient of x, so they need to add to 2. So I bet there will be a 4 and a 2. Now for those to add to plus 2, I need to put a negative sign here. And this gives me the factorization. X plus 4 times x minus 2 is equal to 0. A product of two factors is 0 if either the first one is 0, which occurs when x is negative 4, or if the second one is 0, which occurs when x is 2. And that gives us our two x-intercept, negative 4 and 2. If you want to know where the vertex is, it's going to be exactly in between the two, so you can either do it graphically or you can find the average of your two values. And now if we want the y-coordinate of the vertex, this v stands for vertex, we just sub this value, the negative 1, into this expression. And we get negative 1 squared plus 2 times negative 1 minus 8, so that's really 1 minus 2 minus 8, and that's negative 9. So we know that our vertex is this point here, and its coordinates are going to be negative 1 and negative 9. And that's enough to get a fairly good feeling of what our graph looks like. So we get this on this side, and we get our beautiful parabola. And we are ready to try to do the second half of the question. So that's y is equal to x squared plus 2x minus 8. Without knowing anything except the definition of the absolute value, we can sketch the graph of that. So first, if I'm looking at these points here, f of x, or if you'd like, y is positive. So when I take their absolute value, well, as we know, nothing happens. So that's going to be the graph for absolute value of x squared minus 2x. Same thing for those. Y is positive, so when I take the absolute value, I get the exact same thing. Now let's look at these other values. If I look at the vertex, its coordinates are negative 1 and negative 9. So I need to take the absolute value of negative 9, and of course I get 9. Now at this point here, its absolute it is negative 8. The absolute value is 8. And if I look at this point here, the y coordinate is negative 4. When I take the absolute value, I get plus 4. And you'll start to see what happens here. As we know, the absolute value makes everything positive, so whatever was below the x-axis would correspond to negative values of y. Once you take the absolute value, you get the corresponding positive value. So whatever was below the x-axis has been reflected in the x-axis and is now above. So using this example, we could figure out the rule. If you want to graph y is equal to absolute value of f of x, first you graph y equal to f of x, and then you leave as is the portion of the graph that are above the x-axis, and you reflect the portion of the graph that are below the x-axis in the x-axis, meaning that now everything is above the x-axis, so everything should be on or above the x-axis. Let's look at another example. Again, what is inside the absolute value is well known. That's a cubic, and we know how to sketch a cubic. So the first thing we will do, we will actually sketch the cubic. So step 1, we will sketch y is equal to x minus 1 times x plus 1 times x plus 2. We're very lucky because it's already factorized, so it means finding the x-intercept will be really easy. We get the x-intercept when y is 0, so the product is 0, means either the first one is 0, or x plus 1 is 0, which occurs when x is negative 1, or when x is negative 2. That's our third fact. Let's see what this looks like. So if x is 1, x is negative 1, 1, or x is negative 2. At that point, we know that the cubic could look either like this, or it could look like that, and we need to decide between these two shapes. There are actually several ways to do that. A pretty common one is to look at what happens when x goes to infinity. So as x approaches plus infinity, this will become infinite, so really big and positive. So the three of them will be really big and positive. So as a result, y will be really big and positive. So it will also go to plus infinity. And that solves our problem. It's this one. So we sketch that. So we know that's, oh sorry, wrong pen. That's the way it goes this way. And then it looks like that. So what we've been sketching is this one, the one without the absolute value. Now we will add the absolute value. And we will do just as before. All these numbers here, all the y coordinates of these points are positive. So if you take the absolute value, a positive number, you've done nothing. So if you take the absolute value, you get the same thing. Same thing for those. Absolute value of some positive numbers, you're doing nothing. Now here, you have some negative numbers, and when you take the absolute value of a negative number, the result you will get will be the corresponding positive one. So this is going to be reflected in the x-axis. So now your red curve is y equal to absolute value of the cubic, whereas the green one is the same but without the absolute value. It is important to realize that we've been using the exact same method for these two examples, although the results look different. Step 1, we've been sketching the graph of the function without the absolute value. And then after doing this, we reflected whatever was below the x-axis in the x-axis so that now it's above. That's what we've done here and there.